Hello everyone. I, Priyanka, along with my teammate Suma, will be presenting our research on security control in cloud computing under the guidance of Professor Ming Yang. So moving on to the next slide, I would like to break the presentation into the following topics, mainly focusing on cloud computing, security in cloud computing, few security control techniques followed by AWS, Azure, and Google Cloud, then possible future research directions, and more. Can you go to the next slide, Suma? Yeah. So so we're going to discuss more about cloud computing. So cloud computing is the delivery of various services over the internet. Cloud computing has been around for approximately like more than 2 decades now, as many businesses have transferred their data from on-premises to the cloud. There are many advantages of cloud computing, mainly reliability, virtualization, data storage, and low prices. Cloud computing works in a similar way to web based email clients that allows users to access all of the system's functions and files without having to retain majority of the system on their own computers. Many reputable firms are drawn to cloud services because of these unique qualities. But the biggest and the most important concern is security, and that is what we're going to focus on here in this presentation now. So when it comes to adopting to a cloud computing solution, many businesses are concerned about security. After all, making sure that your files, applications, and other data are secure, if they're not kept on site, is utmost important. For various reasons, there have been numerous cloud security breaches in recent years. Data breach, data loss, cloud storage misconfiguration, malicious activities, and other cloud computing security vulnerabilities are some of the examples. So, working on ways to maintain confidentiality, integrity, and availability is critical. And our study focuses on assessing and comprehending the implementation of new techniques and approaches to keep data secure in cloud. So we have investigated Amazon Web Services, Azure, and the Google Cloud Service providers to examine their data security approaches and methods in cloud. Can you go to the next slide, Suma? Yeah. So the term cloud security refers to the methods and technology used to protect cloud computing infrastructures from both external and internal cyber attacks. The first step in securing the cloud is to recognize that it is a shared responsibility. So, in other words, unlike a traditional on premises system where the host and the user are the same organization, a cloud environment involves a number of different parties. So, cloud service providers are responsible for protecting the physical infrastructure and virtualization stack in an infrastructure as a service or IaaS arrangement, while the rest, such as hosting, data, middleware applications, and so on, is the responsibility of the cloud client. So we will be focusing on a few security control techniques in the upcoming slides. So moving on to the next slide, um, uh, these are some of the popular methods followed by some biggies. So data protection is the technique of securing a company's data in a cloud environment, regardless of where the data is located, whether it's handled internally or externally by a third party. So the technique of encrypting or modifying data before it is sent to cloud storage is called cloud encryption. Encryption is a process of converting unencrypted data, such as text, file, images, into an unreadable format, that is ciphertext, that can be hidden from unauthorized users. So there are several key points to answer the question why companies need access control, and some of them being flexibility to maintain synchronized data and to enforce restrictions like IP restriction, time restriction, and session timeout, and more. Uh, so moving on to the next point, theft, leaking, and destruction of data stored online are all threats to cloud security. Firewalls, penetration testing, tokenization, virtual private networks, and avoiding public internet connections are all the methods for providing cloud security. Moving on to the next slide. Yeah, so here we're going to discuss more about the authentication and identity techniques, and also access control techniques. So some of the authentication and identity techniques are session-based authentication and token-based authentication. So in session-based authentication, after the user logs in, the server will create a session for the user. The session ID is then saved in the user's browser as a cookie. The cookie will be transmitted with each future request as long as the user is logged in. The server can authenticate the user's identification by comparing the session ID saved on the cookie to the session information kept in the memory and sending a response with the appropriate state. So for authentication, many web-based applications employ JSON web tokens that can be seen in token-based applications. So the client saves the JSON web tokens and includes it in every request header. When the server receives a request from the client, it validates the JWT, that is JSON web-based token, and sends a response. Apart from the authentication identity verification needs, even IT infrastructure has a unique problem. It may be required to restrict specific users access to certain information if a company has more than a few employees. So it is reasonable because people or groups of employees should only have access to data related to their jobs and should not be allowed to see information that is not related to their jobs, such as financial or customer data. Some of the famous access control models are mandatory access control, discretionary access control, and role based access control. So, moving on to the next slide, we're going to discuss about encryption in cloud and data recovery. So many businesses prefer to encrypt data before storing it on cloud. Data is encrypted before it leaves the company's environment, and only authorized parties with correct decryption keys can decode it. So other cloud providers can encrypt data as soon as it arrives, ensuring that all the data is kept uh, or transmitted in a secure way. While certain cloud service providers may lack encryption, encrypted connections such as HTTPs or SSL should be utilized at the very least to ensure that data is secure while during transmission. With new technologies altering the modern corporate scene, having a variety of recovery options is also very crucial. So individuals and businesses are increasingly turning to cloud backup and recovery solutions, but they're especially useful when corporates needs to back up large volumes of data, such as contents of an entire data center or something. So while minimizing infrastructure costs and administrative duties. Companies can use its own backup software offered by cloud provider or software given by third party service providers. In all the instances, the backup application picks files for backup, creates encrypted copies of data, and sends it to an offsite backup location. So from here, my teammate Suma will take over the presentation and continue with the rest of the slides.
Thank you, Priyanka. Hello, everyone. I'm Suma. I'll take you over different security controls that are being used in popular cloud service providers like AWS, Azure, Google Cloud, and IBM. So let's take a look at AWS Security Control. AWS Security Control is the world's largest cloud service provider, and they are very popular. It's almost being used in either big or small organizations. And the best practices and the security controls have already been discussed by Priyanka. So let's just take a look what are the security controls that they are trying to include in their day-to-day activities. So the first one is network and infrastructure security. That is, to have all the up-to-date anti-virus softwares, and then to provide different layers of security related to infrastructure. And then host and endpoint security. This is securing endpoints and entry points of end users such as desktops, laptops, and mobile devices. Data encryption and protection, governance, risk and compliance, logging and monitoring of different data security files, and then threat detection analytics. So they have different models built already using machine learning that is going to detect the threat, and that's going to display if there's any threat detection on the dashboard, and they're going to use this data for future control of security. And then there's identity and access control, where the user is first identified if he's authorized user or not, and then basis the access control that is already provided to him, system enables him to access the only tables or probably the software applications that he's allowed to access. And then vulnerability and configuration analysis is nothing but they use the third party assessments through which they conduct external vulnerability assessment and penetration tests. And this is basically cost effective. So most of the companies try to have vulnerability and configuration analysis done through third party. And then application security, that is to provide security measures at the application level that aim to prevent data or code being hijacked by hijackers. And then security engineering, nothing but security engineers ensure that the information system is safe, and then they try to monitor the logs of this security system regularly. And the last one is security operations and automations. Nowadays, automation is also being applied in security control, where they try to automate a lot of manual tasks. So these are a few security controls that are being followed in AWS. Moving on to Azure security controls, they have web application vulnerability scanning and penetration test. So we have already learned in our class what penetration test is, and then authentication and authorization in Azure App Service, that is to authenticate and then authorize the user. And then layer security architecture, nothing but different layers of security controls are being put into measure. And then Azure role based access control, that is the access are defined to different roles, and they are not given standard access. It's basis their roles, they're given access. And then encryption in transit is nothing but the data water is being transmitted from the whatever the data is being transmitted from one system to another system is being encrypted, and upon arrival the end user decrypts the data for usage. Anti-malware, nothing but which focuses on new threats, whereas antivirus keeps you protected against the traditional versions like worms and phishing attacks. Moving on to Google Security Control, they use user authentication. I think encryption at rest and encryption is very popular. So I think Google also uses them. Deletion of data, nothing but it avoids the attacker to use the data that is being deleted. For example, if company does a backup and it deletes any unwanted data, sometimes user tries to attack the data that is already deleted. So company should ensure that even the deleted data is safe and secure. Secure boot stack and machine identity, nothing but it establishes a trust relationship between bootloaders and software it eventually launches, and then it avoids unauthorized software updates that could happen prior to the OS launch. Denial of service protection, nothing but it denies any suspicious software update or service that is being sent from other system to the client system. Intrusion detection and reducing insider is nothing but ensuring that company is actively or proactively taking care of any threat detections, and then trying to reduce any insider threat that is being identified. Last one is nothing but the IBM security control. Even they use user identification and access control, networks isolation and protection, enable data security at rest in transport and in usage, cybersecurity threat management, operations method, cyber risk management. That is, they have a separate team that manages the cybersecurity and keeps updating about the risk, like if the risk is a medium or if it is highly impacting, something like that. So those were some of the popular security controls that are being used in different cloud service providers, that are being used by different cloud service providers. So let's take a look at future research challenges. So though we ensure that the cloud service providers take care of security controls at most, still there are chances that the attackers try to find new ways to hijack the system. So that's the main concern nowadays. So cloud security architecture and strategy are lacking. So organizations need to work more on security architectures and build a very high standard model and make it very difficult for anyone to hijack their systems. Their strategies have to have a very strong mission and vision. Threat inside the organization is something that is very scary, because you don't know who is doing that inside the organization. So ensuring that no threat inside the organization is equally considered as important as threat outside the organization. So that makes the organization safe and doesn't lead to any security breach. Interfaces and APIs have been hacked, and that keeps happening. And because I keep seeing a lot of articles that talks about interfaces and APIs that are being hacked, so organizations should pay more attention towards such cases. So I think those are some of the future research challenges. Probably everyone should pay attention in order to have a better and safe, information systems. So talking about conclusion, most popular techniques are already being adapted in these companies to secure data. But as world keeps evolving with different technologies, so does the threat. All the companies should keep themselves updated with the latest technologies and dive deep to understand, what are the different new threats or antiviruses that are being used by hijackers, and ensure that the information systems or their organization data is safe. So we have taken information from these following references. So yeah, so that's the end of our presentation. Thank you for listening to us.